Hi and Assalamualaikum. I will begin with the introduction and molecular structure of hyaluronic acid. Hyaluronic acid or HA is a naturally occurring special carbohydrate classified as glycosaminoglycan. Unlike simple sugars that are mainly associated with energy storage, HA functions mainly as a structural and biological molecule. It is widely distributed in the extracellular matrix of connective tissues, especially in the skin, joint, and eyes. One of its unique characteristics is its ability to attract and retain large amounts of water, which helps maintain tissue hydration, lubrication, and mechanical support. Structurally, hyaluronic acid is a long, linear, and unbranched polysaccharide made up of repeating disaccharide units. Each repeating unit consists of two monosaccharides, D-glucuronic acid and N-acetyl D-glucosamine, connected through glycosidic bonds. These repeating units form a long polymer chain, giving hyaluronic acid its unique three-dimensional structure and allowing it to attract with water molecules. This special structure is the reason why hyaluronic acid has become valuable in regenerative medicine and drug delivery application.
First is the physical properties. This substance looks like a viscous gel-like material. It has viscoelastic properties, which means it can absorb shock and flow slowly, not like water. It also highly hydrophilic, meaning it can attract and hold a large amount of water. In terms of solubility, it is very soluble in water but not soluble in organic solvent. Lastly, it biodegradable, which means it can be naturally broken down in the body, so it is safe for medical use like injection. Next is the chemical properties. Its chemical formula is based on repeating unit with a large molecular weight. It is weakly acidic and carries negatively charged carboxyl groups. It is stable at normal body condition, especially pH 4 to 8, but it breaks down in very strong acid or base. It is also stable up to around 60 to 70 degrees Celsius, but will degrade above 80 degrees. Finally, it is biocompatible and non-toxic, but it can be broken down by enzymes in the body. I will briefly explain the biological roles of hyaluronic acid. First, it helps to keep tissue hydrated by holding a large amount of water, especially in the skin, joint, and eyes. Second, it provides structural support as part of the extracellular matrix, helping to maintain tissue strength. Third, it plays an important role in wound healing by helping the body repair damaged tissue. Fourth, it acts as a lubricant in joint and eyes, reducing friction and allowing smooth movement. Lastly, it helps with cell communication, controlling growth and repair processes.
Next, I'm going to talk about hyaluronic acid synthesis mechanism. This figure shows how hyaluronic acid is synthesized naturally in the body. The process can be divided into three main stages, which is activation of precursor sugars, polymerizations by hyaluronic synthase, and continuous chain elongations. The first one is activation of precursor sugars. First, two sugar precursors are produced. The first precursors of UDP glucuronic acid or UDP gluc-UA, it starts from glucose, which is phosphorylated by hexokinase to form glucose 6-phosphate. This is then converted into glucose 1-phosphate by phosphoglucomutase. Next, glucose 1-phosphate reacts with UTP to produce UDP glucose. Finally, UDP glucose is oxidized by UDP glucose dehydrogenase using two NADP plus molecules, converting the alcohol group at carbon 6 into a carboxylic acid to form UDP glucuronic acid. The second precursor is UDP N-acetylglucosamine or UDP glucanic. It begins with fructose 6-phosphate, which receives an amino group from glutamine to form glucosamine 6-phosphate. This is converted into glucosamine 1-phosphate, then acylated by acetyl-CoA to produce N-acetylglucosamine 1-phosphate. Finally, reaction with UTP forms UDP and acetylglucosamine. These two activated sugars serve as the building blocks for hyaluronic acid synthesis. The second step is polymerization by hyaluronic synthase. The second stage is polymerization, which is catalyzed by the membrane-bound enzyme hyaluronic synthase (OHAS). In the first step, the hydroxyl group adds carbon 4 of the terminal glucuronic acid on the growing chain attacks the anomeric carbon or carbon 1 of UDP glucan NAC. UDP acts as a good leaving group and is released, forming a P14 glycosidic bond. Next, the hydroxyl group at carbon 3 of the newly added N-acetylglucosamine attacks the anomeric carbon of UDP gluc-UA Again, UDP is released forming B3 glycosidic bond. During both reactions, the enzyme stabilizes the translation state and ensures that the correct glycosidic bond is formed. Lastly, chain elongations and final product. These two reactions repeat continuously. Hyaluronic synthase alternately adds UDP-gluc-UA and UDP-gluc-NAC to the growing polymer while releasing UDP after each addition. At the same time, the newly formed hyaluronic acid chain is transported directly through the cell's membrane into the extracellular space. The final product is a linear, unbranched polysaccharides consisting of alternating B14 and B13 glycosidic bonds. A single hyaluronic acid molecule typically contains 10,000 to 25,000 repeating disaccharide units and has a molecular weight of approximately 1 to 10 million daltons. These unique structures give hyaluronic acid excellent water-binding ability, flexibility, and biocompatibility. Its properties make it highly valuable not only in skincare but also in regenerative medicines, wound healing, tissue engineering, and drug delivery system.
Now, let's explore the application of hyaluronic acid. While many people know hyaluronic acid as a skincare ingredient, hyaluronic acid is actually play a much bigger role in medicine and healthcare. Number one is skincare and cosmetic. Hyaluronic acid widely used because it can retain a large amount of water and help the skin to keep hydrated, improve skin elasticity, and reduce the appearance of lines and wrinkles. For example, the product we have is Hada Labo Glycogen Premium Lotion and the ordinary hyaluronic acid. Besides skincare, hyaluronic acid is also important in ophthalmology or eye care. It is used in artificial tears to relieve dry eyes and to protect the cornea during eye surgery because of its excellent lubricating properties. For example, include the hyalochromate and Habak eye drops. Number 3 is orthopedic medicine. So the other application of hyaluronic acid is in orthopedic medicine. Hyaluronic acid is injected into the knee joint to reduce pain, improve lubrication, and increase mobility in patients with osteoarthritis. For example, include Hyaluronic injection and Synvix 1. Last but not least, hyaluronic acid is widely used as a dermal filler in aesthetic medicine. It helps to restore facial volume, smooth wrinkles, and enhance facial features such as the lip and cheeks. Well-known examples are Juvederm, Restylane, and Bolatero Balance. So in conclusion, hyaluronic acid is much more than just a skincare ingredient. From eye care and a joint treatment to cosmetic procedure, its wide range of application highlight its importance in improving both health and quality of life.
The next slide is about health implication of hyaluronic acid. Hyaluronic acid gives a lot of health benefits. First is joint health. Hyaluronic acid will act as natural lubricant, help to reduce pain in osteoarthritis patient. The second one is wound healing and tissue repair. Hyaluronic acid help in cell migration and tissue regeneration. The third one is skin health. Hyaluronic acid will retain a large amount of water and helping maintain skin moisture and elasticity. The fourth is eye health. For eye health, hyaluronic acid used in artificial tears and ophthalmic surgery to maintain moisture and protect ocular tissue. Next is potential risk. Potential risk of hyaluronic acid. In generally, HA is safe to be used. The infection site reaction may occur when use HA, such as redness, swelling, and miping. Next is global health challenge. First is aging population. As people age, the natural level of hyaluronic acid in the body decreases, contributing to skin aging and joint degradation. So, based on hyaluronic acid therapy, it may improve the quality of life among elderly population. The second one is chronic wound. As we know, chronic wound are a major global health concern, particularly for diabetes patient and elderly. So, hyaluronic acid-based wound dressing are being developed to accelerate healing and reduce complication. The third one is cancer treatment. Hyaluronic acid may improve treatment effectiveness while reducing side effect to the patient. The last slide is about current research and
innovation of hyaluronic acid. The first innovation of hyaluronic acid is regenerative medicine. Hyaluronic acid-based hydrogel and scaffold are being developed for cartilage repair, tissue engineering, and healing application. The second innovation of hyaluronic acid is drug delivery system. It's bind to CD44 receptor, which are overexpressed in many cancer cells. Researchers use hyaluronic acid nanoparticle to deliver anti-cancer drug directly to tumor site. The last innovation of hyaluronic acid is 3D bioprinting. Hyaluronic acid also used in 3D bioprinting as a bioink. It helps to create tissue structure to support cell growth. For example, bioprinting can implant ear being investigated for microtia restriction, and bioprinting skin is being developed to treat burn injuries and chronic wound.